Okay, these notes are 2.1, two categorical variables. So in these notes, we are going to learn about 3 different types of bar graphs. So looking at our two-way table, this table should look familiar because this was on homework 1 from unit 1. We had 2 categorical variables. One is the region and the other is the political party. So for the first one, it says a side-by-side bar graph merges 2 bar graphs into one in an attempt to compare the distributions of 2 categorical variables. So exactly how we did a bar graph, we're going to do the same thing, but we're going to have 2 bars for each variable instead of just one, because we're comparing Democratic versus Republican. So what I'm going to do first is I am going to draw my graph. I'm going to make sure I label each of my sides. So this is going to be my regions. And this is going to be my frequency, so how often it occurs. And then I had 4 variables. I had Northeast, Midwest, South, and West. And if I look up here, I'm only going to be paying attention to this main data here, because these are telling me the frequencies in which each of these are happening. So looking at all those, it looks like my largest frequency is 12. So when I'm doing my frequency part of my graph, I'm just going to go up to 12, and I'm going to go by 2s. The last thing I need to do before I start doing the bars is to create a key. So this key, I'm going to have one color represent Democrat and the other color represent Republican. So I'm going to go ahead and say pink is Democrat and blue is Republican. So I'm going to start with Democrat. Looking at the table for Northeast, the Democrat was 9 people. So I'm going to use all these numbers for Democrat. So I'm going to go up to 9. For Midwest and South, I'm going to go up to 4. And for West, I'm going to go up to 8. Okay. Each of these would be colored in representing Democrat. Then I would look at the next row and do Republican. Notice for Northeast, there was 0, so I'm not going to draw anything. For Midwest, there's 8. So right next to this bar, I'm going to draw up to 8 in my other color. South was 12. And then West was 5. Okay. So now that I have my side-to-side bar graph done, I want you to notice a couple things. First, notice how we still have gaps between each of our variables. Okay, it's still a bar graph, which means we are not putting all the data together next to each other like a histogram. And each bar is representing one variable, not a range of variables. Okay. Another thing is notice how easy it is to compare the 2 distributions when I'm looking at 2 different colors. So for example, if I was to ask about the South, you would be able to easily say that the Republican Party is more represented in the South versus the Democratic Party based on the height of the bars. So now let's look at a segmented bar graph. So a segmented bar graph is actually going to talk about relative frequency. Okay, remember when we're talking about relative frequency, we know that if we were looking at each of the variables, the relative frequency for each should add up to 100%. So what we're going to do before we create our graph, we're going to create a table off to the side. So I'm going to have Northeast, Midwest, South, and West, and then Democrat and Republican. Just create a table separating each of these. Okay. And then what I'm going to do is I'm going to look at how often the each of the political parties happened with the total frequency of each of the regions. So for example, if I go back to the table and I look right here at Northeast and Democrat, I notice that that happens 9 times out of a total of 9 times. So that means in this first one, 9 divided by 9 gives me 100% of the data. While the Republican part is 0 out of 9, which means this is 0% of the data. And when I'm looking at each of these columns, I should add up to 100%. Okay, Midwest Democrat, so I go back up to the table. Here's Midwest, here's the Democrat, there's 4 out of 12. And then notice the Republican is 8 out of 12. So writing those, I would have 4 out of 12 and 8 out of 12, which would give me 33.3% and 66.7%. And again, notice how I can add this column up and I get 100%. So doing the same thing for South and West, I get 25% and 75% and 61.5% and 38.5%. Now creating my bar graph. Okay, so I have my regions at the bottom, just like before. I have Northeast, Midwest, South, and West, and now I have relative frequency. And remember, the difference is that this is going to go up to 100%. So I'm going to go ahead and count by 20. So 20, 40. Okay. And then what I'm going to do is use the same key that I used above. So my Democrats were pink and my Republicans were blue. So pink and blue. And I'm going to start with my Democrat. So for Northeast Democrat, it was 100%. So notice this bar is going to go all the way up to 100%. For Midwest, it was 33%. For South was 25%. And for West was 61%. Okay. Well, we know each of these columns are going to add up to 100%, which means each of our bars are also going to add up to 100%. So I'm just going to take the other color and make sure that my bar goes up to 100%. Okay, they all should be at 100%. And notice the difference here. So we still have the gaps, right, between each of our variables, but instead of 2 bars, we have the bars stacked up on top of each other. It's still easy to interpret this because we can look at the amount of Democrat versus Republican within each region by looking at which one had most of which color. So for example, again, looking at the South, I know that Republican has more representation here than Democratic because of how much we colored blue versus pink. And then the last one we're going to look at is a mosaic plot. Okay, so what's unique about a mosaic plot is that we're actually going to use the same data we found in the segmented bar graph, but we're going to then calculate the sizes of each group. Okay, and then above sizes of each group, I want you to write width, because this is going to give us the width of each of the bars. And in order to find that width, we are going to take the total amount of each region and divide it by the total of the table. So for Northeast, the total of the region was 9, and the total of the table is 50, so 9 out of 50 is 18%. Same for the rest. I'm just going to go ahead and fill this in. And then lastly, West. Another thing that you'll notice is that all of these percentages should also add up to 100. So again, this is representing the width of the bars. Okay. So drawing my mosaic, I have my region. Off to the side, I have my relative frequency. So that's that same data I'm using in the last one, which was the segmented bar graph. And then at the top here, I have my width frequencies. Okay, so for my frequency, I'm going to go by 20s. Let me redo that so I spread it out a little bit more. Okay, and then the top I'm also going to go by 20s. And remember, these are percentages. Okay, and what I'm going to do is I'm first going to do each of the regions width. So Northeast was 18%. Okay, so that's Northeast. Midwest was 24%, so 18 plus 24 is 42. So this is my Midwest. South is 32, so 42 plus 32 is 74. And that is South. And then 74 plus the West of 26 is going to get us all the way up to 100, and that is, again, West. And then using the same key I did before, so Democratic and Republican, Democrat, pink, Republican, blue. Okay, I'm using these values here, which means that each of my bars should look like this. Okay, so drawing that out, starting with Democrat. Democrat was the full 100%. Okay, Midwest, it went up to, let me double check this, Midwest 33. South was 25 and then 61. So 25 and then 61. And then you'll notice that another big difference between these ones and the other ones is now we no longer have gaps between our bars. What you're going to end up with is just one giant picture of all the colors, or our two political parties. So it says when you're working with two categorical variables, most of the time the raw data is given in the form of a two-way table. It is a table listing two categorical variables whose values have been paired. Each set of numbers in a two-way table have a specific name. So now we're going to look at some definitions here. So we have joint relative frequency. That is the ratio of the frequency in the cell divided by the total of all the data values. Marginal relative frequency is the ratio of the sum of the row or column. So think of it almost like the total of the row or column divided by the total of all the data. And then conditional relative frequency is the ratio of joint divided by relative based on what the problem is giving you. So you would ultimately see this as a sentence stem here. You would see this as, this would be when you find the percentage of people that blank given blank. So in our previous example, it could be the percentage of people that voted Republican given they lived in the South. Okay. So bringing this table back in, what we're going to do is find our joint, marginal, and conditional relative frequencies. So the first one for joint relative frequency, it wants us to find the percent of states that are in the Midwest that voted Democrat. So Midwest, right, that voted Democrat, it overlaps at 4. So this is 4 divided by the total data, which is 50. So that's 8%. Then we would look at marginal relative frequency. And this is saying the percent of states that are in the South. So we look at South. The number in the south are 16. 16 divided by the total 50 give us 32%. And then lastly, conditional relative frequency says of the states that voted Democrat, okay, so that's this, of the states that voted Democrat, the percent that is from the West. Okay. So that first part here is always going to be our sorry, lost for words, denominator. Next one is going to be our numerator. So of the states that voted Democrat was 25, so that's our denominator. The percent from the West, that's our numerator, so 8. 8 divided by 25 is 32%. Okay. Now let's look more into conditional relative frequencies. And given this new table, we have two categorical variables here. One that is talking about people who completed a popular health science certificate program, and notice that the only answer choices are either yes or no. And then people who completed more advanced studies, yes or no. That's how I know it's categorical. So it says, which statement is true about these 100 students? So A says, being a person who completed more advanced studies, so completed more advanced studies, is more likely than being a person who did not complete more advanced studies. So that's someone who said yes to advanced studies. So studies, yes. If we look at our table, the amount that said yes would be 40. And then this is the one still with studies, but then who answered no, and that would be 60. Well, it's saying the first thing is more likely than the second thing. Is 40 greater than 60? Since we would say no, then we would say this is a false statement. Okay. Next says, being a person who completed the program is less likely than being a person who did not complete the program. So now we're saying program, yes. And looking up at our table, that would be 60 people. And then program, no, which would be 40 people. So it's saying the first one is less likely than the second one. Is 60 less than 40? Since we answer no, this is false. This one says, being a person who completed the program and completed more advanced studies. So that's program, yes, and studies, yes. So we have to see where that overlaps. So going back up here, who completed the program, yes. Okay, that's right here. More advanced studies, yes, that's right here. They overlap at 35. So this would be 35. Next one says, person who did not complete the program and did not complete more advanced studies. So it's the same thing, but now no. So the people that said no to both was also 35. So it's saying the first one is less likely than the second one. Well, is 35 less than 35? No, so this is false. Next one says a person who did not complete the program but completed advanced studies, and then a person who completed the program and completed more advanced studies. So it would be program, no, but studies, yes. And then looking at the table, that would be 5 people. And then the other one, which is program/studies, which they answer yes for both. We looked at that one in part C, and we found that to be 35. So it says the first is less likely than the second. Is 5 less than 35? Well, since that is a true statement, we would say true. Lastly, it's a person who completed the program but did not complete more advanced studies, and a person who did not complete the program and did not complete more advanced studies. So this one is program, yes, studies, no, which is 25. and then did not complete and did not complete. So this is program/studies, no, and we did that again in part C, which is 35. So it's saying the first is more likely than the second. Is 25 greater than 35? Since we say no, this is a false statement. Next example says a 1969 study investigated the relationship between a mother's diabetic status and the appearance of birth defects in her children. The results appeared in a two-way table. So we have two categorical variables. One is diabetic status with three types: non-diabetic, pre-diabetic, and diabetic. And then the other one is birth defects with two types being no, they didn't have a birth defect, or yes, they had a birth defect. So part A says fill in the row and columns with the totals. Well, we're just adding the total for each row and adding the total for each column. So I'm going to go ahead and fill that in. Then it says compute the conditional distributions of birth defects for each diabetic status. So that's the one saying yes, they had birth defects, and then we're picking each of the diabetic status. So we're going to have three different answers here. So we have birth defects given non-diabetic, ND. So that would be 31 that said yes on non-diabetic over the total for non-diabetic, which is 785, and that gives us 4%. But let me make sure I put it in decimal. I'm going to say 3.9% instead of rounding it. And the next one is birth given pre-diabetic. So this is 13 out of 375, which is 3.5%. And the next one is birth defects saying yes given diabetic, which is 9 over 47, which is 19.1%. Ultimately, what we're doing is we are creating our relative frequency table in order to create our segmented bar graph. So in this table, we have non-diabetic, pre-diabetic, and diabetic, and then we have no to birth defects and yes to birth defects. Okay. Well, we already found all the yeses. This was 3.9, 3.5, and 19.1. And we know the total in each column is supposed to be 100%. So I can do 100 minus 3.9 and get 96.1. Or 100 minus 3.5 and get 96.5. And then the same thing and get 80.9 for diabetic. So now that I have that, I can create my key, and I'm going to say no is yellow and yes is green. So I have my diabetic statuses, non-diabetic, pre-diabetic, and diabetic. And then I have my relative frequencies, which I'm going to start at 20 and go all the way to 100%. So starting with my yeses, I'm going to do 3.9. Well, maybe it'd be easier to start with my no's. It doesn't really matter which one you start with. So 96.1, and then 96.5, and then 80.9. So these are all of my yeses, and then my no's are just going to top it off to make sure that I get all the way up to 100%. So looking at this, it says, can you comment on any clear associations? Well, if we look at each of these bars, we'll notice that diabetic is the only one that has the greatest yes for birth defects. So we could say there appears an association of more birth defects in diabetic women. Okay. Remember, this is an association, not a correlation. We're not saying that if you have diabetes, you are guaranteed to have a child with birth defects. There's so many different things going on with this data that later on you'll find that this is not the most accurate way to show this data, because if we go back up and we look at the totals and the table, notice that the totals for diabetic was 47 compared to the totals for non-diabetic, which is 75. So obviously our percentages are going to look a lot more significant for diabetic when we're taking a number and dividing it by something smaller versus taking a number and dividing it by something larger. Okay. Also, we don't know all the other factors that happened with these women. Maybe there was people who were diabetic who were also smoking, okay? Because smoking can cause birth defects as well. Maybe there was people who were also drinking, which can cause birth defects as well. So we do not know the other factors going on here. So just keep in mind that even though we were able to draw an association, that doesn't mean that's a correlation, something that always happens. Next example says 4th grade children were asked what emotion they associate with the color red. The responses for emotion and gender are summarized in the following two-way table. It says, what proportions of males associate the color red with love? Well, here's the males, and here's love, so we're looking at the overlap. So that would be 38 over the total males. Well, if we add up all the total males, we get 38 over 112, which is 0.3393, which is letter choice C. And then last example here, we see that we're trying to disprove the stereotype that everybody in LA has a cell phone. So these researchers collected data on several people who lived in California, some of them specifically in LA and others from other parts of California, and they asked them, do you own a phone? Yes or no? So here is our data table, our two-way table. Here is two different segmented bar graphs, okay? These are both accurate graphs, but just showing two different things. The first graph here is looking at if they're in LA or they're not in LA, and the segmented portion is whether or not they own a phone. Versus the other segmented graph is do they own a phone versus do they not own a phone, and then the segmented portion is if they're in LA or not in LA. So part A says, what plot would make it easier to answer the question, are LA people more likely to own a cell phone than other Californians? So what I would do is I would look at the table that has in LA and not in LA in the variable on the x-axis, because that's what our problem starts with. It says, are LA people more likely? So we need to look for in LA, not in LA. So we would say the left graph, since the first variable is on the x-axis. Then it says, what does the other segmented bar graph tell you? Write a sentence or two based on the other graph. So if the first graph is telling us, are LA people more likely to own a cell phone, and they had LA versus not in LA in the x-axis, and ours have owns and does not own, we should probably start our question with if you own or if you do not own a phone. So you would say if you own a cell phone in California, do you most likely live in LA. Okay, notice how we started off our question based off of what that first variable is on the x-axis.